Good afternoon. I am Shailendra Singh Ojha, Assistant Professor in Department of Electronics and Communication Engineering. Today we are going to discuss the concept of oscillators. Actually, oscillators are the circuits which can generate signals, which can generate waveforms. That waveform can be sinusoidal waveform, triangular waveform, or a square waveform. So before starting the oscillators, let us talk about the Barkhausen criteria. Actually, if I will talk about Barkhausen criteria, so before discussion of this criteria, let us talk about the feedback, which we have already discussed. There are two types of feedbacks. One is the positive feedback and another one is the negative feedback. For negative feedback, again with feedback, AF is equal to A upon 1 plus A beta. This is for negative feedback. For positive feedback, AF is equal to A upon 1 minus A beta. This is for positive feedback. So you can remember that we would like to get AF is equal to infinite. When it will be infinite? When magnitude of A beta will be equal to 1. And one more thing, this sign should not get changed into positive. Otherwise, it will convert into the negative feedback. So when it will become negative, when the phase shift between the amplifier and feedback will be either 0 degree or 360 degree, and obviously the integral multiple of 2 pi. So these two conditions, one is this, and total phase shift should be 0 or 360 degree, and magnitude of the product of open loop gain amplifier, open loop gain of amplifier and feedback factor beta should be equal to 1. That means these two conditions are known as Barkhausen criteria. As you know, that in case of oscillators, input signal need not to be applied. They will provide you output without application of input signal. Obviously, we will give supply, we will give the supply voltage so that the device can operate properly, but yes, we will not give any kind of input. This circuit has the capability to provide output without applying any input. If I will categorize oscillators, then oscillator can be categorized into various category, but I am categorizing here into two parts. One is the RC oscillators and another kind of oscillators are the LC oscillators. It depends on the component. And one thing that we need to remember is this, that if you will see here, in both the cases, either capacitor or inductor and capacitor are involved. That means oscillator cannot be designed with the help of simple resistive networks. So let us discuss RC phase shift oscillator. This is amplifier. This is the feedback network, which consists of 3 RC networks. Why we are going to use 3 RC networks? You can see here that if I will consider one RC network, then V0 upon Vi can be obtained as this, and the phase shift that will be provided will be equal to tan inverse Xc upon R. So ideally, you can see that when R will be equal to 0, we can get phase shift of 180 degree. But practically, R will not be equal to 0. So we cannot get phase shift of 180 degree. Actually, you may think that why I am talking about 180 degree, from where the concept of 180 degree came into the existence. Actually, you will use amplifier. Either you will use BJT, you will use MOSFET, and in common emitter configuration and common source configuration, they will provide phase shift of 180 degree. Then extra 180 degree we need to obtain from this feedback network. From this feedback network. That's why I'm talking about 180 degree. So practically this 180 degree phase shift cannot be obtained with the help of two RC networks, because this value cannot be 0. So it can, so by choosing proper values of C and R, you can get desired phase shift, whatever phase shift you want. That means two RC network cannot work. 3 or more than 3 network can work means they can provide phase shift of 180 degree. But if we can obtain phase shift of 180 degree with the help of 3 RC networks, then what is the need to go for the more number of networks? Because we never want to use the more components unnecessarily. So we can use 3 RC networks. One RC network will provide phase shift of 60 degree and 3 RC networks will provide phase shift of 180 degree. This is the reason that whenever you will see RC networks, RC phase shift oscillators, you will always see 3 RC networks. So just to find out the value of the frequency of oscillation, or what frequency this circuit is going to generate, and it can be obtained with the help of the analysis of this circuit. So I have taken this RC phase shift network. I am considering current flowing through this branch is I1, I2, I3 and V0. And this node is as V2, this node is denoted as V1. So V2 is equal to I3 multiplied by this impedance plus V0, the voltage drop across this R. So V2 will be equal to this, and it can be simplified as this. And you know that V0 is also equal to I3 into R, because this whole current will pass through this. So you can say that I3 value is known to us. So now you can put this value and you can find out V2. Similarly, by writing this equation of I2, you can find out V2. And at node V1, you can put V2 is equal to I2 upon j omega c, and this value we have already found out, and you can put this value here and you can get V1. And again apply KCL at node 1, you can write I1 is equal to this, and we can find out this I1, and simply we can find out Vn. So Vn is this, and now we can convert this Vn in terms of V0. So Vn is equal to this into this whole factor 1 plus 6 upon j omega c, Cr minus 5 upon omega square c square r square minus 1 upon j omega q cq rq. So you can remember one thing, that whenever you will derive an expression for f0, if you will derive an expression for the frequency of oscillation for any kind of oscillator, then you need to equate the imaginary terms to 0, or in other words, we can say that this factor should be, or this input and output, this factor should be independent of the imaginary terms. It should be full real part. So how it can be real part? When imaginary part will become 0. So imaginary part means this is the imaginary term j 6 upon j omega CR, and this. So you can write it like this into j into the j will be cancelled out. So you can find out omega square c square r square is equal to this. This means 1 upon 6. So omega will be equal to 1 upon under root 6 RC. That means f is equal to 1 upon 2 pi RC into under root 6. So if you'll put this value of omega here, or simply you can omit these two and you can directly put omega here, then you will get V naught multiplied by this term is equal to V in. So you can find out V naught upon V in is equal to minus 1 upon 29. So in this way, negative sign indicates the phase shift of 180 degree. So you can remember that. See, don't get confused that this is the output of feedback amplifier. No, this is the output of feedback network, input of feedback network. That means it is minus 1 upon 29. That means feedback factor is 1 upon 29. That means beta is equal to 1 upon 29. And negative sign means phase shift of 180 degree. So remaining 180 degree we need to obtain from the amplifier. And this, if this beta is equal to 1 upon 29, and you know, according to Barkhusen criteria, A beta is equal to 1. That means amplifier gain should be equal to 1 upon 29. If it is 1 upon 29, it will go towards right hand side, then it will become 29. So if beta is equal to 1 upon 29, which we have already obtained, then A should be equal to 29. Now this is the IC phase shift oscillator. You can see this is the network. That means RC phase shift network. Its output is applied to the inverting terminal of operational amplifier. Why inverting terminal? Because if you will apply any input at inverting terminal, it will give you phase shift of 180 degree. And its gain is RF upon RI. That means it should be equal to minus RF upon RI, it should be equal to 29 because we need to obtain this value. Now this circuit can also be designed with the help of FET. You can see here. FET, these are the normal things, and in feedback network we have connected this RC network, and for this F is equal to 1 upon 2 pi under root 6 RC. Gain, magnitude of gain is GMRL, and RL is the parallel combination of RD and small rd, which will be, so it will be equal to capital RD multiplied by small rd upon capital RD plus small rd. And this is the BJT version of RC phase shift oscillator. You can see here, everything is like this. So 1 upon 2 pi RC, 1 upon under root 6 plus 4 RC upon RC, where RC is this resistor which is connected into the collector terminal. You can easily understand this. So for BJT, F is equal to this, and HFE, that is beta, that is again it is equal to 23 plus 29 R upon RC plus 4 RC upon R. And simply you can also draw the IC phase shift oscillator like this. Now you can have numerical, and these type of numericals can be easily solved with the help of this relation, that is C is equal to 1 upon 2 pi R C into under root 6. So C will be equal to 1 upon 2 pi R F into under root 6. So if something is provided like they have provided the value of R, then you can put value of R and you can solve it. Now, there are some advantages of RC phase shift oscillator, like the oscillator circuit designing is easy with basic components like resistors as well as capacitors. This circuit is not expensive and gives excellent frequency stability. These are mainly suitable for low frequencies. This circuit is simpler compared with the Wien bridge oscillator because it doesn't require any kind of stabilization, planning and other things. The circuit output is sinusoidal, that is somewhat distortion free, and it can work nicely from 0 hertz to few kilohertz. They have applications in musical instruments, GPS units, voice synthesis. The application of this phase shift oscillator includes voice synthesis, musical instruments, and GPS. So, in this way, you can understand the importance of RC phase shift oscillator, and this is how we can find out the derivation for the F naught, which is equal to 1 upon 2 pi RC into under root 6.